Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, we'll be beginning the exercise 4.3 from Mathematics class 12th based on the chapter Determinants. Today is the turn of exercise 4.3 and we'll be discussing all the questions associated with this exercise one by one. The topics that are covered in this exercise are related to application of determinants, something called area of a triangle. Yes, how do you find area of triangle given the coordinates of 3 points, and given the area can you find some condition on the coordinates, or on the other hand given that you have 3 points which are collinear, what's the condition in terms of determinants, right? In the form of determinants, what's the condition related to that? On the basis of that you can also find the equation of straight line passing through two given points. Now all of these things have been covered in this exercise over here. This is a relatively simple, easy exercise, small exercise, and we'll be covering them one by one. Let's say the first question that we have is find the area of the triangle with vertices at the point given in each of the following. Now, what are we supposed to do in this one? Not much. We are simply supposed to use the idea of determinants to find the area. How can you find the area? For a triangle having vertices A, x1, y1, B, x2, y2, and C, x3, y3, the area of the triangle can be found very easily. Area of triangle ABC will be equal to 1 by 2. 1 by 2, yes, there's a factor 1 by 2. And then you write the vertices x1, y1, 1. This is the determinant. This is the 3 by 3 determinant that you get using the vertices. Vertices x1, y1, x2, y2, x3, y3 over here. Right. And you multiply with a 1 by 2, and this is the area of the triangle. Mind you, this value of the determinant may come out to be negative. But remember that area is positive, so you'll have to take the absolute value of this. This particular determinant may come out to be negative, so in that case, you'll have to focus on taking the absolute value since area has to be positive. Has to be greater than 0, right? So in case you get a negative answer, convert that into positive by taking the absolute value, right? Okay. So let's try to find that area. We are given the vertices 1, 0, 6, 0, and 4, 3. So area of triangle will be equal to what? Half of the determinant will be 1, 0, and you have a 1, 6, 0, and you have a 1, 4, 3, and you have a 1 over here. And this is what you'll have. You have 1, 1, 1 over here, x1, y1, x2, y2, x3, y3, and you have a half multiplied over there. What else? We are simply supposed to solve this determinant. This is half, which is okay. The value of the determinant can be found very easily by expanding along. Yes, this column over here, this column has 2 zeros, right? So we'll just need this 3, term having this 3. So what will be here? Plus, minus, plus, and this will be a minus. So minus 3, actually minus 0 plus 0, and minus 3 times the determinant of 1, 6 and 1, 1. This is what we are interested in. This is what we are interested in. Okay, so this is 1 by 2, which is okay. Minus 3 is okay, and this determinant will be 1 minus 6. Yes, and what is this? This is minus 5 times minus 3 is 15 by 2 is what you get, and that's my answer for this question. 15 by 2 is the area of this triangle over here. Is that all? Yes, that's all in this question. Let's move on to the next one after this. Once again, we are supposed to find the area of this triangle over here having the coordinates 2, 7, 1, 1, and 10, 8. How do we go about finding the area? The approach is once again very easy and simple. Directly find the area using determinant. Okay, the first vertex, as you can observe, is 2, 7. So we'll write 2, 7. The next is 1, 1, and the third one is 10, 8. The third column will be 1, 1, 1. This is what you'll have. Is that okay? Yes. What else? What else? Let's take a look at this. This is, once we have written this much, then we can use properties of determinants, or we can directly expand the determinant. Both the approaches are okay. That's not an issue. So which one do you think we can use? There are many ones over here. We can use properties and try to convert them into zeros. Yes. Let's try to convert them into zeros. 1 by 2 is okay. 2 minus 1 is 1. 7 minus 1 is 6. And 1 minus 1 is 0 over here. Yes. Okay. 10 minus 1, 1 and 1, let it remain as it is. 10 minus 1 is 9, 8 minus 1 is 7, and you have 1 minus 1 as 0. This is what we have. Is that okay? Yes. And now we can expand along this column and we get the value of the determinant very easily. What you get is plus minus plus, plus 0 minus 1 times determinant of 1697 and my plus 0. This is what you get. Is that okay? Yes. Therefore, area becomes equal to what? Half of this determinant over here. This is minus 1 times 7 into 1, 9 into 6. Okay. 7 minus 9 times 6 is 54. 7 minus 54 is what I get. 1 by 2 is okay. Minus 1 is okay. And then you have 7 minus 54, which is minus 47. This is what you get. Minus 47. And this will give me actually 47 by 2. That's the area. That's the area that we get. That's my final answer for this question, as you can clearly see over here. Is that all? Yes, that's all for this question. Let's discuss this question next. The question says find the area of triangle. Yes. And the three vertices are given. Minus 2, minus 3, 3, 2, minus 1, minus 8. So what are we going to do? We're going to do a similar thing as we have been doing up till now. And area will be equal to the determinant. Area will be equal to the determinant half times the determinant of this. Minus 2, minus 3. This is what we'll have. 3, 2, minus 1, minus 8 is what we'll have. 1, 1, 1 is what we'll have over here. And this is the area for us. Okay, in case the value is obtained negative, we'll take the absolute value obviously. And let's see, since there are a lot of ones, one thing that we can do is try to create some zeros first of all before expanding. Another idea is to expand directly without worrying about anything along any row or column. So what I would like to do is, I would like to create some zeros first, right? Let's try to create some zeros. Okay, let's take minus 2, minus 3, 1, let it remain as it is. 3 minus or minus 2 will become 5. 2 minus or minus 3 will become 5 and this will be 1 minus 1, 0. Is that okay? Yes. Next, minus 1 minus of minus 2 will become 2 minus 1, which is 1. Minus 8 minus or minus 3 will become plus 3. Therefore, minus 8 plus 3 will be minus 5. And you have a 0 over here. 1 minus 1 is 0. Is that okay? Yes. That's pretty simple. What else? I can create some 0 here also, but another thing that can be done is simply expand along this column. And if you expand along this column, what you'll get is this. 1 times the determinant that you'll get is 5, 1, 5, minus 5, okay, minus 0 and plus 0. This is what you'll get. Is that okay? Yes. Therefore, area will be equal to what? 1 by 2 times 1 times this determinant, which is minus 5, 5 into minus 5, minus of 1 into 5, which is minus 25 minus 5. And obviously, we'll have to take the modulus, the absolute value. And since we have to take the absolute value, what we'll get is, this is minus 30 by 2, which is minus 15. The modulus will be equal to 15. And yes, that is my answer for this question over here. Right? Is that okay? Yes, that's okay. That's all that you have in this question. Oh, you brought that modulus out of nowhere? No, I did not bring it out of nowhere. I simply said that you have to take the absolute value. So modulus was always present over here, just that I have not written it over here directly. Right? That's all that you have in this question. Let's move on to the next one after this. Show that the points A, B and C are collinear. Now, how do you show that the points are collinear? There's a simple idea behind showing collinear points using the concept of area of a triangle. Let us say you have 3 points like this. They're forming a triangle, right? A, B and C. And you have some area of this triangle. Area will be area of this region, right? In case there's a possibility that if this is B, this is C, and the point A, instead of lying over here, if the point A actually lies over here, what we'll have is this triangle. Triangle will have AB, AC and BC sides, and the 3 points ABC, when they are collinear, do you observe that the area of triangle ABC is simply equal to 0. Area is simply equal to 0. This is using the idea of determinants. That is something which you can say. So we'll use the exact same logic over here and we'll show using this idea that the points are collinear. What's the idea? If the area of triangle ABC is 0, then the 3 points A, B and C are collinear. That's the important thing. Once you have that important idea in front of you, then you can simply note that area of triangle ABC. Let's try to find the area. This is equal to what? You have given the coordinates A, B plus C, B, C plus A, C, A plus B, and you have the third column as 1, 1, 1. This is what you have, right? What to do next? You please observe that C1 can be replaced by C1 plus C2 and you will get A plus B plus C, B plus C plus A and C plus A plus B, which is same actually, right? This will give me half of A plus B plus C. This will be B plus C plus A, which is same as A plus B plus C. C plus A plus B, which is again same as A plus B plus C. Oh. So what's the use of this? You see the last column over here is also 1, 1, 1. We have the same terms over here. The middle one is a bit complicated. Let it remain as it is. But do you observe that if you take out A plus B plus C common from this column, what you'll get is 1, 1, 1. Okay, this is 1, 1, 1 and this is already 1, 1, 1. If both the columns are exactly same, the value of determinant will be yes, 0. The value of determinant will be 0. And since area of triangle ABC is 0, that implies that ABC vertices are collinear. That's the important observation which you have seen over here. That's the proof of this. We were supposed to show that these points are collinear. This is a way in which you can show that these points are collinear. Let's move on to the next question after this. Find the values of K if area of triangle is 4 square units and vertices are this. Okay, area is given. Okay, so the value of half times determinant will be equal to 4 or no, it will be plus minus 4. Yes, we'll have to consider both the values, the positive as well as the negative value. Find the values of K if area of triangle is 4 square units and vertices are this. So area can be written as 1 by 2 K 0 4 0 0 2 and the last column will be 1 1 1. This value can be plus or minus 4. Remember that, right? Once you know that much, then what you can do is simply expand this determinant along something. Let me write this value K 4 0 0 0 2 1 1 1. This will be equal to plus or minus 8. Do you observe that? That 2 will come over here. And now let's expand. Let's expand along this C2, that's second column. There are 2 zeros in this column, right? So you'll have minus 0 plus 0 and minus 2 times. Minus 2 times what you have is 1K and 4 1. K 4 1 1. This is what you'll have, plus or minus 8. Therefore, minus 2 times this K minus 4 is equal to plus or minus 8, and from here you can observe that K minus 4 divided by minus 2, what you get is minus plus 4. This is what you get. Therefore, one of the values using the minus wala and using the plus one, what you will get is K minus 4 is equal to minus 4. Here you will get K minus 4 is equal to plus 4, and therefore this or this, both values are correct. So K will be 0 from here or K will be 8 from here, and yes, those are the possible values. K equals 0 or K equals 8. That's my answer for this question. Is that okay? Yes. That's very simple. K equals 0 or K equals 8. Let's move on to the next one after this. The next one says find the values of K once again, and you are given some points minus 2, 0, 0, 4, 0, K are the vertices. The area of triangle is 4 square units. A similar question to the previous one, and we can solve it very easily using this idea that area minus 2, 0, 0, 4, 0, K, 1, 1, 1 times half. This area will be equal to plus or minus 4. Right? This area will be plus or minus 4, and we can solve this determinant very easily. This half will go that side, and we expand along the first column. Minus 2 times determinant 4K 1 1 is plus or minus 8. Is that okay? Yes. Therefore, this gives me minus 2 times 4 minus K is equal to plus or minus 8. That further tells me that minus 8 plus 2K, or for that matter, let me divide by minus 2 first. Let me divide by minus 2. What you get is K minus 4 is equal to minus plus 4. Dividing by minus 2 both sides. And the plus sign will give me something. The minus sign will give me something else. Let's use the plus sign or the minus sign. What you get is 4 minus K is equal to plus 4. Using the plus sign, and or you get 4 minus K is equal to minus 4 using the minus sign. This will give me K equals 8. And this will give me K equals 0. The correct answer is K is equal to 0 or K is equal to 8. That's the correct answer for this question over here. Is that all? Yes, that's all that you have in this question. Let's solve this question next. The question says find equation of line joining 1, 2 and 3, 6 using determinants. Now, how are we supposed to find the equation of line The approach is pretty simple. It is related to collinearity. Collinearity, yes. Let's say we have a point A and another point B over here, right? And if we want the equation of line, we basically are looking for some point P having coordinates x comma y. If these are given, find coordinates of any random P having coordinates x comma y such that points P, A, B are collinear. If you can manage that, then the relation in terms of x and y, that linear relation will actually be the equation of this line. So that's a simple idea, and using that idea, let's solve this question. What do we have? We have 1, 2, 3, 6 and another point, that is P x comma y. So we have A 1, 2, B 3, 6, and let P x comma y lie on the line. Therefore, P comma A comma B are collinear. That's the condition that I need to apply, which implies that area of triangle PAB is 0, or you can say alternatively that the determinant that is formed, half times determinant is 0, or the determinant is simply 0. The value of the determinant is simply 0. That is 1, 2, 3, 6 x, y, and you have a 1, 1, 1. This is what you have, right? Is that okay? Yes. And let's solve this. It's pretty easy to solve this one. What we can do is, let's get rid of this. Okay, this is not required. So next, what I can do is I can simply expand along the last row. Can I? Yes. So what I'll have is plus minus, the sign will be plus x. Okay, and you'll have a determinant over here which is 2, 1, 6, 1. 2, 1, 6, 1 minus y minus y times 1, 3, 1, 1. That's what you have. 1, 3, 1, 1 plus 1 times 1, 2, 3, 6. This is what you have. This value is simply 0. That will give me the final equation very easily. What is that equal to? Let's observe this is 2 minus 6, which is minus 4x. Then you have a minus 5, 1 minus 3, which is minus 2. Okay. And you have a plus 1, 6 minus 6 equals 0. This is what I'm getting, right? What does that give me? This is minus 4x plus 2y and plus 0 equals 0. Or you can say that this 4x will go that side. 2y equals 4x, or y equals 2 times x is the required equation of line joining these 2 points, 1, 2 and 3, 6. This is a line y is equal to 2x. Is that all? Yes, that's all that you have over there. Using the determinant form, you can find the equation very easily of this line having these 2 points, 1, 2 and 3, 6 lying on it. Given any 2 points, you can find that. Let's move on to the next question after this. The question says find equation of line joining 3, 1 and 9, 3 using determinants. Let's use determinants once again to find the equation of line. So P x, y, A 3, 1 and B 9, 3 are collinear. That's the condition that I need to apply, and on applying this condition, what I get is that a determinant value is equal to 0. Area equals 0, which implies half times determinant, or you can say the determinant is equal to 0. Okay, determinant formed using these points, right? Let's write x, y, 1, then we can write 3, 1 and the last column will be 1, 9, 3 and the last column is 1. Oh, in the previous question you wrote x, y at the bottom. Will it make any difference? No. I can interchange and still the value will be 0. The determinant changes in sign. Will it make any difference? Since the right hand side is 0, it will not make any difference, right? Which point should I take first? Which point should I take second? Well, it will not have no impact on this particular question, right? So we can take x, y here or here as well, right? So what you have is, let's expand along the first row. Plus x, then you have 1, 3, 1, 1 minus y plus x 1, 3, 1, 1, y times 3, 9, 1, 1. This is the determinant. My plus 1 times 3, 1, 9, 3. This is what you get, equals 0. Let's simplify this further. This gives me x times, you get 1 minus 3, which is minus 2. Minus y times 3 minus 9. 3 minus 9 is minus 6 actually. Let's write that, minus 6. And plus 1 times what you get is 9 minus 9, which is simply 0, equals 0. This is what you get. This becomes minus 2x plus 6y is equal to 0, or you can say 6y is equal to 2x. Therefore, you can say that 3y is equal to x. This is the required equation. Y is equal to x by 3 or 3y equal to x is the required equation of this line joining the points 3, 1 and 9, 3. Is that all? Yes, that's all that you have in this question. Move on to the next one. If area of triangle is 35 square units with vertices 2, minus 6, 5, 4 and k, 4, then k is, what is the value of k? That's the question. So area is given and vertices are also given, right? If area is given, we'll consider both values, that is plus and minus, right? Remember that. And once you remember that, we can directly say 2 minus 6, 5, 4, k, 4. Then the last column will be 1, 1, 1. This determinant times half is equal to area, which is plus or minus 35 square units. That's the equation. Now solve this equation to get the value of k. That's very simple, and we can easily solve to get the value of this determinant. So for solving, should I create some zeros first? I can. Or I can directly expand along this column over here. Let's expand. Half will go over there. This will become 70. 2 times the determinant will be 4, 4, 1, 1. Okay. Oh, this is coming out to be 0. Yes, this is coming out. If we subtract, this will be 0 only. So it would have been easier if you would have subtracted R3 minus R2, right? But let's see, since we are beginning in this direction, minus 5 times what you get is minus 6, 4, 1, 1. Then you have plus k times minus 6, 4, 1, 1 is equal to plus or minus 70. This is what I am getting, right? Please note this carefully. This is, what is this equal to further? This is 2 times 4 minus 4, which is 0. Then you have 0 is over here, okay, minus 5 over here, and what do you have over here is this. This is minus 6 minus 4, which is minus 10. Note this carefully. Minus 6 minus 4, which is minus 10, plus k times minus 6 minus 4, which is again minus 10. Okay, plus or minus 70 is what I have in the right hand side. What else? That is 0. This is 50. So this will give me 50, and minus 10k is equal to plus or minus 70. Let's divide by 10 first of all. Do you see a factor of 10 everywhere? Yes. Let's divide by 10. This becomes 5 minus k is equal to plus or minus 7. From here, k will be equal to 5 plus 7, 12. Or k will be equal to 5 minus 7, which is minus 2. Those are the possible values of k. 12 and minus 2. 12 or minus 2. Basically, option D is the correct answer for this question, as you can see behind me. Is that all? Yes, that's all that you have in this question. With this, we come to the conclusion of this exercise based on determinants. Application of determinants. Actually, this is exercise 4.3 of the chapter determinants from class 12th NCERT Mathematics. That's all for this session.